Welcome to Revise for Physics, the place where you revise for physics. Okay, in this video I'll be going through some of the specification points from atomic physics from the CIE iGCSE spec. And this is section 5.1.2 titled The Nucleus. Here are the core points that you can see here, and these are the supplement points, so for the higher grades. So some of the basic things about the nucleus. The nucleus is made of protons and neutrons, and that's just a fact that you have to learn. The nucleus is the centre of the atom, as I covered in the last video. And some background information. The smallest possible charge is that of the electron or the proton. The proton is positively charged and the electron is negative. Now because there's nothing smaller than them, that means that they can be given a charge of +1 or -1. -1 for the electron, +1 for the proton. There's nothing else that's smaller, so you can consider that to be the base charge. Quantities in the nucleus, we have the nucleon number, which is sometimes denoted as A, and the proton number Z. So other definitions, a nuclide is, as I've got here, a specific atom or nucleus described by a particular number of protons and neutrons. Nuclide notation is how a nuclide is shown, or shown in writing. It will contain the atomic symbol, the proton number, and the nucleon number. So here's the atomic symbol, here's the proton number, and here's the nucleon number. So you could call that carbon 12 if you wanted to make it nice and simple, because all carbon will have 6 protons. An isotope is 2 or more forms of the same element with different numbers of neutrons but the same number of protons. If it's the same element, like I just said, an example could be carbon, it'll have 6 protons, so the same number of protons, but it might have a different number of neutrons. So it might have, for example, this carbon 12 has 6 protons and 6 neutrons to make up the 12 total nucleons. But you could have carbon 14, which is made up of 6 protons and 8 nucleons. Nuclear fission is when a heavy nucleus splits into smaller nuclei. Sometimes these small nuclei are called daughter nuclei. Nuclear fusion is when the small light nuclei come together to make larger nuclei, and this releases energy. So both these processes release energy. Fusion is when things stick together, when things fuse together. That's when things stick together. So that might be a nice way to remember nuclear fusion. Nuclear fission being the other one. Remember them as a pair. Then there's 3 different types of radiation. There's the alpha particle, which is made up of 2 protons and 2 neutrons. So I've tried to draw the 2 protons and the 2 neutrons here. Now that's just a helium nucleus, and it's shown in this notation. So you've got the alpha symbol for an alpha particle. Then there's also a beta particle. The beta particle is given 0, -1. It's -1 because it's an electron. It's this high energy electron. I've just drawn it as a dot here, but you can just think of it as a particle or an electron. If you remember that it's an electron, that's perfect. That's all you need. So -1 describes what it does to a charge. Now what I mean by that is because -1 has the opposite charge of a proton, you can think of it and just use that minus charge. And that's particularly useful when considering a process called beta decay, which is the decay that releases beta particles. And I'll go into that in more detail at a later video. So what we've got here is balancing nuclear equations. Now it's really important when you're doing nuclear equations to conserve charge and mass. So this is done by looking at the nuclide notation and balancing both sides of the equation. So I've got a very simple equation here. I've got uranium-238, which has 92 protons and 238 nucleons. And when that splits, giving off an alpha particle, like this has here, the alpha particle is 4,2. Those 92 protons take away the 2 protons of the alpha particle, leave this 90 protons. Now anything with 90 protons is thorium. So we've just got numbers. Now these numbers here add to this number here. So it's just the same as balancing a mathematical equation. Uranium-238 has 238 nucleons, but when you take 4 of them out in the form of an alpha particle, that leaves 234. Now the bottom process is a little bit more difficult because it involves the emission of a beta particle. Now in this beta particle here, I have 14 nucleons, a beta particle is emitted, and in beta decay, a neutron turns into a proton. But that doesn't change the number of nucleons, because both protons and neutrons are nucleons. So I need 14 is the same as 0 plus the number here. So that just leaves me with 14. Now I need for this side here to balance with this side here for the proton number as well. Now I need this side, the right hand side of the equation, to add up to 6, because I've got 6 on the left hand side. So I need -1 and a number that adds to -1 to give you 6. So that's just 7. And that forms nitrogen. So nitrogen is formed when carbon-14 undergoes a beta decay. Here's an exam question from CIE where I've gone through the same process. So this is an alpha particle here, and the alpha particle, we know it's an alpha particle because it's got 2 protons and 4 nucleons. Now you could say it's a helium nucleus, and that would be equally correct, but because it's a decay of an isotope, we think of it as an alpha particle, and that's more scientifically correct. But it's interesting to remember that in the mark scheme, the mark was also awarded for saying a helium nucleus. So the question, looking at the balance and nuclear equations skill, is calculate the values of A and Z. So A is really simple to do, as is Z. You've just got to know what you're doing. So you need to know that the 82 and the 2 add together to give the Z. So 82 and 2 just makes 84. And 206 and 4 just add together to give you the 210. Pretty simple. And that was just 2 marks of a question. So these are the specification points again. So we've done the balancing equations last. We talked about some definitions for nuclear fission and fusion. And before that we looked at all of these basic core points here. Hopefully this has been a helpful video. And hopefully there will be more of them in the future to help you. Thank you for watching.